The universe follows rules. This fact feels so normal that we rarely stop to question it. Objects fall. Light moves at a constant speed. Energy is conserved. Cause comes before effect. From the smallest particles to the largest galaxies, everything appears to obey a set of precise mathematical laws. But here is the question almost no one asks. Why does the universe have laws at all? Not what the laws are, not how they work, but why reality follows any rules in the first place. There is no obvious reason it should. The universe could have been pure chaos, events happening without pattern, particles behaving randomly, nothing stable enough to form stars, planets, or life. Yet instead, reality is structured, predictable, ordered. This order is so deep that we can describe it with equations written on a page, equations that work everywhere in the universe, billions of light years away. That fact alone is strange. Physics does an incredible job describing the laws of nature, but physics does not explain why those laws exist. The equations tell us what happens, not why the universe is lawful at all. This question sits at the edge of science and philosophy, and quantum physics pushes it directly into view. At first glance, quantum physics seems to point toward randomness. At fundamental scales, events are probabilistic. Outcomes cannot be predicted with certainty, only with likelihoods. This led many people to believe the universe is fundamentally random. But randomness is not the same as lawlessness. Quantum physics is governed by extremely precise rules. The probabilities themselves follow strict mathematical structures. Random outcomes emerge from lawful frameworks. In other words, even uncertainty has rules. This deepens the mystery rather than resolving it. Why is even randomness structured? Why does probability itself obey laws? One possible answer is necessity. Maybe the universe could not exist in any other way. Maybe laws are unavoidable. Maybe only a lawful universe can exist at all. But this raises another question. Why these laws? The constants of nature appear finely balanced. If many of them were even slightly different, stable matter would not exist. Stars would not form. Chemistry would fail. The universe would be lifeless or short-lived. This has led to the idea that the universe sits in a narrow range of possible laws that allow complexity. Some interpret this as coincidence. Others suggest deeper explanations. One idea is that laws emerge rather than exist fundamentally. In this view, the universe did not start with laws. Instead, laws formed as reality evolved. Early reality may have been chaotic, with patterns slowly stabilizing. Over time, consistent behaviors reinforce themselves. What we call laws might be the universe settling into stable habits. This idea treats laws not as commands, but as regularities, patterns that persist because they are self-sustaining. Quantum physics supports this in subtle ways. At small scales, systems constantly fluctuate, but large-scale order emerges from these fluctuations through averaging and reinforcement. Order does not need to be imposed. It can arise naturally. Still, this does not fully answer the question. Why does order arise at all? Why doesn't chaos dominate completely? Another idea is that laws are mathematical. Some physicists believe the universe is mathematics, that reality exists because mathematical structures exist. In this view, laws are not imposed on the universe. They are the universe. The universe behaves lawfully because it is a mathematical object. This sounds abstract, but it explains something remarkable: why mathematics describes reality so well. Equations written by human minds correspond exactly to the behavior of distant galaxies and invisible particles. It is as if reality is written in mathematical language. But this raises a deeper problem. Why does mathematics exist? And why does it correspond to something physical? Quantum physics intensifies this mystery. At fundamental levels, reality behaves less like physical objects and more like abstract states described by mathematical structures. Particles do not follow classical trajectories. They exist as evolving mathematical descriptions. What we experience as physical reality emerges from these abstractions. This suggests that laws may not be external rules, but internal constraints, consistency conditions that reality must satisfy to exist at all. In other words, laws may be the price of existence. A universe without laws might simply not be able to exist in any stable form. Any reality that exists long enough to be observed must obey some structure. Chaos may be possible, but it may be unobservable. This idea connects to another deep insight. Observation itself requires stability. To have observers, memory, or experience, reality must be consistent across time. Inconsistent realities erase themselves before anything meaningful can happen. This means lawful universes are not just possible, they are the only ones that can be experienced. This doesn't mean the universe was designed for life. It means life can only arise in universes with laws. Still, this explanation feels incomplete. It explains why we observe laws, but not why laws exist in the first place. Another possibility is that laws are not absolute. Some theories suggest that physical laws may vary across regions of reality. Different parts of a larger cosmos could follow different rules. We exist in a region where laws allow complexity. In this view, laws are local. What we call the laws of the universe may only be the laws of our region. Quantum physics allows this possibility. At fundamental levels, the structure of reality may be more flexible than we assume. Laws could emerge differently depending on initial conditions. This means the universe is not governed by laws because it must be, but because this particular configuration happened to stabilize. Still, the question remains hauntingly open. Why does any configuration exist at all? At some point, physics reaches a boundary. Beyond it lies pure mystery, but that boundary itself is meaningful. It tells us that reality is not arbitrary. It is not freeform. It is constrained by logic, consistency, and structure. Quantum physics shows us a universe that is deeply strange, but not lawless. Uncertainty exists, but it is bounded. Probability exists, but it is structured. Reality balances on a knife edge between chaos and order. Too much order, and nothing changes. Too much chaos, and nothing lasts. The universe sits precisely in between. This balance may be the most fundamental law of all, and it may explain why laws exist in the first place. A universe that can evolve, remember, and sustain complexity must operate within constraints. Laws are those constraints. They are not imposed from outside. They are not chosen. They are what remain when reality is possible at all. So why does the universe have laws? Because without them, there would be nothing to ask the question. The laws are not just rules reality follows. They are the reason reality exists.